we are finishing off chapter 6. And chapter 6 is the cosine rule, or as they call it in this book, the law of cosines. And essentially, when you have a triangle, a non-right angle, just a boring kind of anything kind of triangle, you're after finding missing angles and sides. And the sine rule is really good at finding missing angles and sides, but there are two combinations that it can't work with. The first one is, how do you find a missing angle when all you're told are the lengths of three sides? So imagine I have a triangle A, B, C. And this guy's going to be called little b, this is little a, and this is little c. And let's suppose I tell you this is 12, this is 11, and this is, I've got to be careful I make it possible, and this is 8. If I asked you to find angle B, you couldn't use the sine rule. Let me show you why you couldn't use the sine rule. Well, you'd set up the sine rule the usual way. And the first thing you would do is, well, is there any angles I can find? Well, I don't know any, so that ain't going to happen. And I know all three sides, which is great. And I want to find angle B. Do you see that we're stuck? I don't have a pair where everything's checked off. So if you ever get a question where they tell you the length of three sides and they ask you to find one of the missing angles, you are going to have to use the cosine rule. Now, the other situation, and this one you're just going to trust me, I'm not going to go and prove it to you, but if you get a situation where you know two sides and the angle in between, so let's say that's 30 degrees, and you know this is 10, and you know this is 12, right? For example. You cannot use the sine rule to find the missing side A. In fact, you can't use the sine rule to find anything in that picture, right? The sine rule won't work. So three sides, you can't use the sine rule. Two sides and the angle in between, you cannot use the sine rules. So we needed a new rule, right? They kind of knew that when they were doing triangles, that there were certain combinations of information that they couldn't use the sine rule on. And so they had to figure out how to solve that. And that's where the cosine rule comes from. So let me show you the first kind. How to find a missing angle when you're given three sides. So imagine we have a, right, well, just any old triangle. We'll call it ABC. You name the sides in the usual way. So that side's little a, that side's little c, and that side's little b. And let's suppose that we want to find angle A. The cosine rule for finding angle A is a formula. So it's not A over sine A, it's a formula. And it says the cosine of that missing angle is B squared plus C squared, take away little a squared over 2bc. And that is the formula for finding the missing angle A. But can you imagine it might not be A? Can you imagine we wanted to know angle B? Well, that formula is not going to get me angle B, right? That formula gets me angle A. Suppose it's not B I want, suppose it's C. The result is that there are actually three formulas, one for each of the three angles. So there's one for finding angle B, and there's going to be one for finding angle C. The good news is that all three formula are kind of the same.
I have a question.
Yes.
So are those just using the sides?
Yes.
Okay.
So, and because that's the only things you're going to know in this question, you're only going to know the three sides. So the formula only uses what you're given, right? The three sides in this case. Now, that's the cosine of A, right? That's how you're going to find angle A. Does anybody want to have a shot at what this guy is using that as a template?
Is it a squared plus c squared minus b squared over 2ac?
Correct. Someone else go for this one then. Cosine C. What would you do?
A squared plus b squared minus c squared over 2ab.
Right. Well, you agree you only really need to memorize one, and then you can figure out, you know, and couldn't they use P, Q, R, and S, T, V, and any other letters of the alphabet? Couldn't you adjust the formula to suit the naming of the triangle? Because you know sometimes the triangle is called the DEF, right? In which case you have to switch the things around. So that's the formula that we're going to be using, right? Depending on which angle. And the first question I'm going to do on that is number 13. And let me find it. Okay, come on, where are you hiding? You think I'd been teaching for this long that I'd be better prepared, wouldn't you? You think I'd be ready for things by now. But I'm not. Okay. That's not the question. Did you notice I didn't swear there? See, I'm still good. I can still not, you know, swear when I have to. 13, finally found the darn thing. Right. Here we go. Now, the way that they write some of the questions down is not to give you a picture in A, B, C, and then write all the sides and all that stuff. They basically, you draw your own triangle, and it doesn't really matter what it looks like. All the triangle is a place to put the numbers, right? Is a place to put the information. So this is little c, this is little a, and this is little b. And in this question, question 13, you're told little a is 5, you're told little b is 9, and you're told little c is also 9. Oh, well, that's fine. And we're being asked to find missing angle. And let's say, it's this one, angle A. So step one is choose the right formula. So in this case, the cosine of A is b squared plus c squared, take away a squared, all over 2bc. And in this question, that's going to be 9 squared plus another 9 squared, take away a 5 squared, divided by 2 times 9 times 9. Are you comfortable about choosing the right formula, right? And step 2 is what I've just done, right? Put the numbers in. Now I could calculate that right now. I'm not going to, but I could, right? I could find out it was nothing 0.1234. Does anybody want to tell me what should I do to both sides to find A?
Take the inverse cosine.
Now I'm going to do this question in 2 ways. This is the first way. Write that down as a calculation. We will assume that things are in degrees, because, well, they are, but we'll assume that they are. If they wanted the answer in radians, wouldn't they really have to tell you radians? But radians hasn't been used much, has it, in sine rules and so on. So, hit mode, Make sure you're in degrees. Get out of there. Watch the buttons here. Inverse cosine. I've got this mess divided by that mess. Do not type in what I'm about to type in. I want to show you that this is wrong. I'm going to say, oh, 9 squared plus 9 squared, take away 5 squared, divided by 2 times 9 times 9, close brackets. Now, if you superficially look at that, doesn't it look that's the calculation? But website TI-84 has a thing called order of calculations, and in order of calculations, weird things happen, and it's not that guy. I'll hit the answer. I'll either get error or just a wrong answer, and I got error, which is not a surprise. So this is how you have to do it, and it's a bit messy. Inverse cosine, another bracket. Then you can type in 9 squared plus 9 squared, take away 5 squared, close that bracket. So basically, I've put that top line inside its own little bracket. Divide, start a new bracket and put in 2 times 9 times 9 and close its bracket. So basically, top guy in a bracket divided by bottom guy in a bracket. Maybe I should write this down. So it's inverse cosine, a bracket, another bracket with 9 squared plus 9 squared, take away 5 squared in it, close that bracket, divide, another bracket, 2 times 9 times 9, close that bracket, and close one more. You know, you finish the whole thing off. Fingers crossed, I want to see an angle. And the angle is 32.3 degrees to 1 decimal place. Are we comfortable about that? Now, here's some good news. Do you know how some triangles, when you did the sine rule, there were 2 answers? It could have been 32.3, or it could have been, you know, the 147.71, right? That's not happening here. There is only one answer. So the one you get is the answer, right? So you don't need to worry about double choices in that particular situation that we're doing right now, which is 3 sides in a given angle, right? Are you comfortable about that? Right, do you want to see the only slightly different way of coming up with the same answer? Well, here it goes. I'll put it in green so it looks different. You do the cosine of A and you calculate that. So basically you just do, what would that be, bracket, 9 squared plus 9 squared, take away 5 squared, divided by 2 times 9 times 9, and you get that decimal. And then you just do inverse cosine. And then if you want to use the answer, it's second button minus, and there's that 32.3 again. So I essentially did all of this on its own, and then I did an inverse cosine of that answer. That's pretty much what I did. Are you comfortable with how to find a missing angle when you're told 3 sides? Now, if I wanted to find now angle B, right, this one here, there's actually 2 ways to do it, 2 totally different ways. And the reason why there's now 2 ways is if I redraw that triangle, I know this is 9, right? I know this is 5. I know this is 9. There's A. Oh, but I know A is 32.3 degrees now. And here is B, and here is C.
Now that you know one of the angles, you could just use the sine rule, correct?
Exactly. You are ahead of me. Well done. If I wanted to find angle B, I could now use the sine rule. It's okay.
Sorry.
No, what are you going to say?
Couldn't you just subtract the degrees by 180 and then divide it by 2 because it's isosceles?
Yes, you could, but that's a special case for this one question. But you're right, you could. So you can find angle B using the sine rule. Couldn't you also just do another one of the cosine rules and just do it again? Maybe if you're in the cosine rule mode, isn't it just easy to stick to the mode? And I have no idea, so don't quote me on this because I know it's wrong. Can we pretend it's 87.7 degrees? I know it's wrong. Right, let's suppose I found it using the sine rule, or I found that angle using the cosine rule. How would you find the third one?
You could just subtract 32.3 and 87.7 from 180.
And you're done.
So it'd be
Right.
90.
Not sure what it should be. 60
No,
probably.
it would not be 90. Yeah,
Yeah.
60.
Right, or whatever. Yeah, 60, I think. Now, I know that's wrong because I saw Lucy do the same, which is what Katie was saying. That's pretty much it, isn't it? I mean, can you imagine if I give you a triangle with 3 sides, isn't it going to look like this? Right. I'm going to do another one because I think you need to see 2, don't you, to get a good idea. So here is question 14. Here's my triangle ABC again. Little a, little c, little b. And I have A is 6, and B is 7, and C is 8. And we want to find all the missing angles. Which one do you want me to get? I don't need to get A this time. So what one do you want me to get? Oh, how hard a question is that? You can't be wrong. Which one do you want?
Angle C.
Okay. So that means I'm going to use this one, right? So the cosine of C is A squared plus B squared, take away little c squared, all over 2ab. And this is going to be 6 squared plus 7 squared, take away 8 squared, and 2 times 6 times 7. Me personally, I just like to do the whole thing in one go. So to find the missing angle C, we find the inverse cosine of that ugly fraction. So here it goes. Inverse cosine, another bracket, 6 squared plus 7 squared, take away 8 squared, divided by, start a new bracket, 2 times 6 times 7, close that bracket and close one more, and the answer I get is 75.5. It's 1 decimal place. Degrees. As methods go, isn't this a bit cleaner? Right? You want angle A, you use that formula. You want angle B, use this one. You want angle C, you use this one, right? Plug in some numbers, inverse cosine them, boom. You feel comfortable about these guys? Do you need to do another one? Or are you good? We're good. Good. So I said you can't get 2, which is true, right? For any triangle, if you tell me all 3 sides, the most you get is 1. I want to show you a triangle that is impossible. Well, let's make that 6, so it's nothing to do with the numbers being the same. That triangle is impossible. I don't need to do any calculations to find out that that triangle is impossible. If I did do a calculation, what would happen here is that when we hit the button here, this thing, the answer would come out error, right? The calculator would say, ain't possible. But just by looking at it, tell me why that triangle is impossible. One side's 6, one side is 5, and the third side is 15. Why is that impossible as a triangle?
Because the opposite and adjacent should, when they add together, should be higher than hypotenuse.
Yes, well, yes, I wouldn't call them hypotenuse, but what you said was bang on. Shouldn't the 2 small sides add up to more than the 15? Can you imagine trying to draw that thing, try to make it, right? Can you imagine this is 5 and this is 6, right? and this is 15. Now, it's not going to work with 2 pens. If you put these two guys diametrically opposed to each other, isn't the furthest apart they can be is 11? Do you see there's not enough room for a 15? Do you see it's impossible as a triangle, right? So I don't think they've got a question like that, but isn't that a really good multiple choice question? Because shouldn't you be able to look at that and one of the answers will be not possible, right? In which case you would choose that one. So that's probably the only idiosyncrasy of the cosine rule, that for some, it is possible to have a triangle that doesn't exist. And that's okay. If you don't notice it until you've done the calculation, that's still okay. So next thing on my little list is how to find the area of a triangle. Well, you might say, but I know how to find the area of a triangle. It's a half base times height. God, how old were you when you learnt that formula, right? But do you know that that is really only designed for triangles where you know their height? Suppose you are given a triangle and I tell you that this is 15 and this is 10 and that angle there is 32 degrees. And I ask you, right, to find the area of that triangle. Would you agree half base times height ain't going to cut it? Because I don't know the height. And I could probably try and find the height, but I think you'd have a hard time doing it, right? So there must be a way of tackling a question where you're given a triangle where you know two sides and you know the angle in between. And is there a formula for the area of a triangle that looks like that? And the answer is that there is such a formula. So I'm generalizing it as we do. The area of this triangle, if you know these two sides, right, and that angle between, it's a half BC sine of theta. It's also written sometimes as a half BC sine of A. So in this question up here, the area of this triangle will simply just be 10 times 15 times the sine of 32 degrees. Isn't that nice that there's just a little formula that you don't need to do a lot of work on, right? So as long as you know two sides and the angle in between it, the two sides go here and the sine of the angle in between goes there. And you don't even need to give them letters of the alphabet if you don't want to. So let's see what this one is. It's 10 times 15 times sine of 32. And the answer for the area of this one is 79.5 square units, whatever the units happen to be. Are we cool with that? That half AB sine C, half BC sine A.
Where did
Can't
the
remember.
half go?
Where did it go? Did you all caught that deliberate mistake? Right? Did you all catch it? See, I was just doing that to make sure you were paying attention. Does anybody believe that? No, nobody should. It's just a mistake. But I like people to tell me, right? So it's always go for it. Whenever you see me do something like that, mention it. Because other people might not notice it and then they go back and look at their notes and they get confused because they see a half, but then I don't use it and they wonder which is the right thing to do. Now, if I return back to a couple of guys that we've got, if you wanted to find the area of this triangle, wouldn't it be a half 10 times 12 times the sine of 30 degrees. Don't I not even need to call them A, B's, and C's? Okay. If I return to this one, remember that one, question 13? We now know the angle, this angle in here, is 32.3. So if I was asked to find the area, wouldn't it be 1/2 9 times 9 times the sine of 32.3 degrees? And there should be one more. And remember we did this one? And we found angle C, which was 75.5 degrees. Okay, tell me the numbers to find the area of this triangle here. I'll start. 1/2 times what?
7 times
7
6
and 6.
times sine of 75.5.
Right. Would you agree that it's probably easier not to bother with the ABCs when you do the area formula? Because it clutters up the picture a little bit. And all you need to do is, well, what about that 8? Nothing. Doesn't matter. Isn't that 8 totally irrelevant to getting the area? Tell me it. Don't tell me it. Don't matter. That's still going to be the area. Are we okay with how to find the area? We good? Have you noticed that the 4 questions that ask you to find the missing angles are also the same questions that ask you to find the area? Because what you do is you find the angle first so you can get the area. So they kind of combine them in one. So you would find a missing angle, A, B, or C. Once you know that angle, you could then get the area. Quick pause. Any questions? What do you call a boomerang that doesn't come back?
A stick?
Oh, I have told you that one. Okay.
No,
Never.
no, you didn't. I just guessed.
Oh, you were right then. So the last one of that type is going to be question 16. And it says, find the area of this kind of pinkish, whatever color you describe it. This is 100 degrees. And you are told that W is 3, that's that side. And that this is 4, that goes there. And this is 5. And, well, actually, this is 5 and this is 6. Not that matters too much. Right. This kind of question kind of falls into a kind of application area situation because it's not actually a triangle, is it? Yeah, I still need to find the area of this shape. So you have to take what they give you and work with it. Any suggestions about just the starting of this? Is there any ideas about how you might approach this question?
Can you like cut it in half and like find the top half?
Sounds like a good plan, right? I don't know how you get shapes, but don't I know how to get areas of triangles, right? So make it into triangles would be a good starting point. We have 2 different triangles here. We got this one I'll call triangle 1 and this one I'll call triangle 2. Let's forget about triangle 2 now. Focus on triangle 1. Is there enough information in front of you to find the area of triangle 1?
Yes.
Agreed? Yep. So it's going to be 1/2 3 times 4 times the sine of 100 degrees. So here we go. 1/2 times 3 times 4 times the sine of 100 degrees. And I get 5.9 to 1 decimal place. Square units. Okay, put a little bubble around that. That's area 1. Now, we got a problem with triangle 2, don't we? there's not enough information, is there? Right? Any ideas what I should find first in this second triangle, the one called number 2?
You could
I gotta
find, oh, you could find the middle line.
Okay, so I'm going to call this triangle A, B, C, so we have some letters, right? So you've just said find AB, agreed? Now, I'm going to call this guy up here D then, because I've got to give him a letter, right? If I isolate this triangle, I know this is 100 degrees. I know this is 3, and I need this is 4. Where do you think I'm going to go next?
Use the cosine law.
I'm going to try, yeah, going to use a cosine rule. The version of the cosine rule I'm going to use now is this fella here. How to find the third missing side of a triangle, just this side here, right? When all you know are 2 sides and the angle in between. So this is the second situation where the cosine rule has to get used, right? We've done the first one, right? When there's 3 sides and you want to find the 4th one. So let's show you what that formula looks like. So hold that thought, we're going back to that question, but here we go. Just my generic EBC triangle again. Little a, little b, little c. That is good. Now, if you want to find side little a, okay, the formula for doing it is b squared plus c squared, take away 2bc cosine of a. Can you just trust me? That's the formula, right? Now you know b and you know c and you know the angle between them, right? You know b, you know c, and you know the angle between them. So that's what you're going to be told, right? Suppose it was little b that I wanted, side b. How do you adapt this formula to find little b? So it starts with b squared equals, what comes next?
A squared plus c squared minus 2ac cosine b.
And for completeness sake, what would little c get you? So c squared is equal to what? What would c squared be equal to?
A plus B minus 2AB cosine B.
Almost.
Oh, cosine C.
The way my brain works is it starts with an A and it finishes with an A. Starts with a B, it finishes with a B. Starts with a C, finishes with a C, right? And if you start with an A, isn't everything else B and C? If you start with a B, isn't everything else the other 2? If you start with a C, isn't everything else the other 2? Right. So you need 3 flavors of the cosine rule when you want to find a little missing side. Now we are coming back to this guy, but let's just do one with the letters A, B, C first. Suppose I tell you that this angle is 75 degrees and that this side is 10 and this side is 15, right? Then I would be after the third side, right, Lily? So the formula, so that would be step 1, is use the formula. And so it would be a squared equals b squared plus c squared. Take away 2bc cosine of a. And once you've chosen the right version of the formula, you then plug in the numbers. So that's going to be 10 squared plus 15 squared. Take away 2 times 10 times 15 cosine of 75 degrees. It's quite a long expression. What do I need to do then to find a? Because this formula tells me what a squared is equal to, but what do I do to find a?
Take the square root of that.
Now, the nice thing about this calculation, even although it superficially looks a lot uglier than the other kind, you don't need to worry about brackets inside brackets. You just need to type it in pretty much the way you see it. So here goes. Square root. 10 squared plus 15 squared. Take away 2 times 10 times 15 times cosine of 75. Make sure you finish with enough brackets. And the answer that we got is 15.7. Are you comfortable with how we found the third missing side in a triangle when you know two sides and the angle between? This is a classic cosine rule situation, right? Where the cosine rule is the only one that's going to work. Now that I know this, right? I know this is 15.7. How would I find angle B? Right, I now know three sides. How would I find angle B?
You could use the sine rule.
I could. Could I use the cosine rule as well? I know three sides, yeah?
Mm-hmm.
Does it matter? No. Whatever one you like best. Once you know B, whatever's left gets you C. So you can solve a triangle. Oops. Right.
You go to
Yes.
you go to the hospital?
Matthew, I think we're hearing your conversation. You probably don't want us to hear it.
Oh, sorry about that.
No, you didn't know it. Are we good? Right, let's return back to this question. Kind of lose track of what the goal was, right? So we need to find this side here, don't we? That was the goal, right? Find AB. Now, the lettering is a little bit different, and you just have to live with the lettering that you've got. In this case, then, won't this be called little a? This will be called little b, and won't this guy be called little d? And so the formula for finding the side D is d squared a squared plus b squared. Take away 2ab cosine d. So d squared is going to be 4 squared add 3 squared. Take away 2 times 4 times 3 cosine of 100. And so d is going to be the square root of all that stuff. So here goes. Square root of 4 squared add 3 squared. Take away 2 times 4 times 3 times cosine of 100. And the answer I get is 5.4. Which means I now know that guy. So if I got to my picture, I now know this guy is 5.4. Okay. Now that's triangle 1, by the way. this is the guy that I'm actually interested in finding the area, right? Triangle 2. This side is still 5.4, this is 6, and this is 5, right? What will I now need to find to allow me to get the area of this triangle?
Angle C.
Okay. Or angle A,
Or
or
whichever
angle B,
one. Yeah.
whatever one you want, but angle C will work. So do you see how this question has got so many levels? It's not like one question, do this and you're finished. Then we have to do something, then something, and then something yet again. I've forgotten, you said angle C, I think you said, okay. Well, if I'm going to do angle C, it's going to be cosine of C, and it's going to be one of my guys over here. Have I got them handy? Not dumber. Cosine C, how are you going to get, what's the formula look like for that?
A squared plus B squared minus C squared over AB times 2.
Okay. So in this case, it's going to be, I guess a bit, little a is 5, little b is 6, and little c is that guy. So it is going to be 5 squared added to 6 squared, take away 5.4 squared, all over 2 times 5 times 6. And won't c be the inverse cosine of that stuff? So let's see what the inverse cosine of that ugly expression. Now this one you do need a lot of brackets. So an extra bracket, 5 squared, add 6 squared, take away 5.4 squared, close the brackets, divided by, start another bracket, 2 times 5 times 6, close the brackets, and get 57.9. Okay, so that angle in there is 57. Let's start again. Is 57.9. Third time. 57. Oh God. Oh my brain. 57.9 degrees. Finally got it. Now, after all that hard work, you might have forgotten what we were doing it for. Weren't we going to do it to find the area of the triangle? And so this bottom triangle, and we pretty much know everything that we need. This guy here is 57.9 degrees. And so what we're looking at here is the area of triangle 2 is going to be 1/2 5 times 6 times the sine of 57.9 degrees. So 0.5 times 5 times 6 times a sine of 57.9. And I get 12.7 for that one. So we now have the area of 2. And so the area of the shape is just 5.9 and a 12.7 added together. And that's the area of the whole shape.